LeetCode Problem 94, Binary Tree Inorder Traversal. Given the root of a binary tree, return the inorder traversal of its node's values. Example 1. The root is 1, 0, 2 and 3. The output is going to be 1, 3 and 2. Example 2. The root is 1, 2, 3, 4 and 5. The output is going to be 4, 2, 5, 1 and 3. The approach that we're going to be taking is called the iterative inorder traversal, which requires a stack data structure. It has a time complexity of O of n and a space complexity of O of h, where h is the height. This will be the optimal solution to this problem. Now let's walk through an example. 1, 2, 3, 4 and 5. Step 1, we want to declare 3 variables. A stack, which is an empty array, a result, which is also an empty array, and the current node, which is going to point at the first node in the tree. Step 2. While the current node is not null, or the stack has a length greater than 0, we need to do the following 2 things and apply this logic on the right hand side. So, while current node doesn't equal null, we can see that it's 1, so it doesn't equal null. We then push the current node to the stack. So we put 1 in the stack, and then we update the current node and set it equal to the current node dot left, which we can see is the 2. So we can see the current node is not null, so we want to push the current node to the stack. So we'll add the 2 node to the stack, and then we'll update the current node and set it equal to the left of the 2, which is the 4. And again, we check while the current node is not null, which it's not because it's pointing at the 4. We want to push the 4 node into the stack, and we update the current node to the 4 nodes left, which is null. So while current node is not null, it is null, so we can skip inside the while loop. We'll set current node equal to the stack pop, which is the 4. We then want to push the value of the 4 into the result, so we'll put 4 in there. We'll update the current node to point at the right of the 4 node, which is null. And back up here, we skip the while loop because it is null. We then pop from the stack. So we've now got the 2 node, which we popped from the stack. We then push the value 2 into the result. And we update the current node equal to 2 on the right, which goes to the 5. Then we say while it's not null, then we want to push the 5 node to the stack, update the current node to the left node of the 5, which we can see is null. So we ignore what's in the while loop because it is equal to null, and then we set the current node equal to stack pop, which is the 5. We then push the 5 to the result. We update the current node equal to the right side of the node 5, which we can see is null. So we skip the code in the while loop, and we set current node equal to the 1 that we've just popped off the stack. We then push the value 1 into the result, set the current node equal to the right node on the 1, which is the 3. And then we know the current node is not equal to null, so we push the 3 node onto the stack. We update the current node to equal the left node of the 3, which is null. So we check here in the while loop, so we can skip what's inside the while loop because it is null. We pop the 3 off the stack. We push the result of the current node's value, which is 3, into the result. And we set the current node equal to the right node of the 3, which is null. And now we can see that current node is equal to null and the stack has a length equal to 0, so we'll break out of the while loop. Step 3, we'll return the result, which is 4, 2, 5, 1 and 3, which is exactly what we were looking for. And that's it. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Let's look at LeetCode Problem 94, Binary Tree Inorder Traversal, in Java. Given the root of a binary tree, return the in-order traversal of its nodes' values. Example 1. We're given this binary tree, and the output is going to be 1, 3, and 2. So 1, can come down to the left, 3, and then to the 2. Example 2. We're given this input, which we can visually see here, and the output is going to be, so we go all the way to the left, starting at 4, then to the 2, so 4, 2, then we come down and left, 6 and 5, so 6 and 5, then to the 7, then back to the top, to the 1, 7 and 1, then to the 3, because there's nothing on its left, so we go to the 3, then we come down and to the left, which is 9, and then finally the 8. So 3, 9 and 8. Cool. Example 3, we are given an empty tree, so the root is going to equal null. And then example 4, we're given a tree with a single node. Cool. So in terms of edge cases, there's a couple of edge cases that sort of come to my mind. The first one is going to be where we're given a empty tree where root is equal to null. In that scenario, as you can see, we need to return an empty array. Because you can see that the return type is a list of integers. So you want to return just an empty list, basically. Example 4 shows another edge case, which is where we're given a single node in the tree. In that scenario, again, you just want to return the value of that single node. And then another edge case, which is sort of demonstrated in example 1, is where we have some nodes that do have a left child, left child, and we've got other but no right child, and then we've got one where we have no left, but we do have a right child. So again, your solution's going to need to handle that particular edge case. Cool, now let's get into it. So the first thing we're going to do is we're going to declare 3 variables. So we'll have a stack, which I'll call stack, which is going to be a stack of tree nodes, or tree node. Call it stack equals new stack. Secondly, we want the result, which is going to be a list of integers. So I'll just take that from here. We'll call it result. We'll set that equal to a new array list. And finally, we want a current node, which is going to be of type, which is going to be a tree node. And we'll call that current node. We'll set that equal to root. Cool. Then the next thing we want to do is we want to use a while loop to loop over each node in the tree. So we'll say while current node doesn't equal null, or the stack is not empty. So stack is not empty. Cool. And then what we want to do is we then want to traverse to the leftmost node in the tree. So we'll use a while loop again, and we'll say while current node is not equal to null. Then we want to take the current node and we want to push it onto the stack. So we'll do stack dot push current node. And then again, we want to go set the current node equal to current node dot left, because we're trying to get to the leftmost node. So current node equals current node dot left. Cool. And then once current node is equal to null, it means that we've got to the leftmost node. in that scenario, now what we want to do is we want to set current node equal to the last node that we pushed onto the stack. So we do stack.pop. Then we want to process the current node that we've just popped off the stack and add it to the result. So we'll do result.add current node.val. And then because we've gone all the way left on the tree, we now want to go to the right hand side. So we'll set current node equal to current node.right. And then basically this is then going to go back up to the top here and re-execute this logic following obviously the same logic. And then finally, once current node does equal null and the stack is empty, that means that we've iterated over every single node in the tree. So what we want to do then is we just want to return the result. Cool. So let's run that, see if it works. It does. Now we'll submit it and see if it passes the tests. It does, excellent. So in terms of runtime, it says it beats 100%, and memory it beats 46.63%. I can tell you that the runtime complexity of this solution is O of n, and the space complexity is O of h, where h is the height of the tree, and that's because each level of the tree it's pushing to the stack. So the stack is going to grow as obviously the height increases. And this is the optimal solution to this problem. I hope that this has clarified the problem and solution for you. If you like the video, if you could please click like, that would be greatly appreciated. And if you could click subscribe, that's going to hugely help me and the channel out, and then more people can see this content. If there's any videos that you'd like to see in the future, or there's anything that you think I can improve on, please leave that in the comments below and I will get back to you. Thank you very much for watching and good luck with your coding.